G'day and welcome. We're kicking off our biostatistics series by tackling the absolute fundamentals, data types and scales of measurement. First up, the word data is technically the plural of datum, which just means a single piece of information or an observation. In any study, the thing we're actually measuring, counting, or observing is called a variable. Why? Because its value varies or changes from one person or sample to the next. Let's make that real. Think about a group of patients in a hospital. What could we measure? Their blood pressure. That's a variable. It's different for each patient. Their age. That's a variable. Their gender. That's a variable. Their pain level on a scale of 1 to 10. Also a variable. Their blood type, A, B, AB, O. Yep, another variable. All of these are our raw data. Now, straight away, you can see that these variables aren't all the same type. Age and blood pressure are measured in numbers, but gender and blood type are described with categories or labels. And just like that, you've got the two main types of data, categorical or qualitative data. This is data that sorts things into categories or groups. It's about quality. Numerical or quantitative data. This type of data is about numbers. It's the answer to questions like how much or how many. It's about quantity. But to know what we can do with this data, like what maths or stats we can use, we need to know how it was measured. This how is what we call the scales of measurement. Let's start with the categorical data. Nominal scale. Nominal just means name. These are categories that are just labels. There's no order or ranking to them at all. So, as you can see on the table, for a nominal scale, data can be categorized, but it doesn't have an order. The difference between variables can't be measured, and it doesn't have a true zero. Examples: gender, male, female; blood group, A, B, AB, O; marital status, single, married, divorced. One isn't higher or better than another. Brown hair isn't greater than black hair, they're just different labels. Ordinal scale. Ordinal means order. These are categories, but now they have a meaningful rank or order. On the table, you'll see ordinal data can be categorized and it does follow an order. But, and this is the key, the variables are not evenly spaced. The difference between them can't be evaluated, and it also doesn't have a true zero. A perfect example is stages of cancer. Stage 1, Stage 2, Stage 3, and Stage 4. We know Stage 4 is worse than Stage 1, but the difference between Stage 1 and 2 isn't necessarily the same as the difference between Stage 3 and 4. Other examples: wound size, small, medium, large; disease severity, mild, moderate, severe; pain scale, no pain, mild, moderate, severe. A quick but really important note: sometimes we assign numbers to categorical data, especially for stats software. For nominal data, we might code red hair equals 1 and brown hair equals 2. But that 2 isn't more than the 1. It's just a label. You can't do maths on it. 1 plus 1 doesn't equal 2. It doesn't mean red hair plus red hair equals brown hair. For ordinal data, we might code mild equals 1, moderate equals 2, severe equals 3. The numbers show the order, but you still can't do maths. The gap between 1 and 2 isn't guaranteed to be the same as the gap between 2 and 3. Right, let's jump back to our other big branch, numerical data. This branch also splits into two types. Discrete data, these are numerical values that you count. They are whole numbers. Integers, the number of equipment used in surgery, the number of patients with a disease. You can have 3, 4, or 9 patients, but you can't have 3.5 patients. Continuous data. These are numerical values that you measure. They can take on any value within a range, including decimals or fractions. Examples: height of a person, or the weight of a newborn baby, or the temperature for storing vaccines. Basically, if you can, in theory, get more and more precise by adding decimal places, it's continuous. Just like with categorical data, we have scales for numerical data: interval scale and ratio scale. Interval scale. On an interval scale, the numbers have an order, and the interval, or space between them, is equal and meaningful. Looking at our summary table, interval data can be categorized. It does have an order, and the variables are evenly spaced. The key difference? It doesn't have a true absolute zero. The classic example is temperature in Celsius. The difference between 10 degrees Celsius and 20 degrees Celsius is the exact same as the difference between 20 degrees Celsius and 30 degrees Celsius. But 0 here is just an arbitrary point. 0 degrees Celsius doesn't mean no temperature. It's just the point where water freezes. Because there's no true zero, you can't multiply or divide. 30 degrees Celsius is not twice as hot as 15 degrees Celsius. Ratio. Scale. This is the top level. A ratio scale has everything an interval scale has, but it also has a true zero. A true zero means the complete absence of the variable. And as you can see on the table, it ticks all the boxes. It can be categorized, it has an order, the intervals are evenly spaced, and it has a true absolute zero. Examples: height, weight, and volume. 0 kilograms means no weight. Blood pressure: 0 millimeters of mercury means no pressure. Heart rate: 0 beats per minute means no heartbeat. Because we have a true zero, we can finally make ratios. This is why we can say a 4-kilogram baby is twice as heavy as a 2-kilogram baby. That statement makes perfect sense. 1. Last important point. Remember this: a single concept can often be measured on different scales, depending on how you decide to collect the data. Let's take weight. I could ask patients for their exact weight in kilograms. That's numerical, ratio data. Or I could classify them into groups: underweight, normal, or obese. And now I've turned the exact same concept into categorical, ordinal data. How you choose to measure your variable is one of the most important decisions you'll make. That's it for our first part of the Biostatistics for NCLEX series. If you're preparing for the NCLEX, make sure you subscribe to Logical Pharmacology. We logify the tricky stuff so you don't have to cram it.